So today we are going to finish up the last method of factoring, and we're going to be factoring trinomials. So this is going to be part 3. So the first one that we're going to talk about are factoring trinomials when we have a which is equal to 1. And let me tell you what this means. This a equals 1. Remember, when you have a trinomial, it needs to be written in standard form. So we need to write the largest exponent all the way down to the constant. The a that I'm referring to is going to be the number that's in front of x squared. So I know this looks like a q, but this is an a. So, and then the number that is in front of x, that is your b, and then the number without a letter is your c. This is standard form. So the beginning part of these notes are the easy trinomials where there's not a number in front of x squared. So these are the steps that we will follow in order to factor trinomials where a equals 1. So my first example here is x squared minus 7x plus 12. First, what I need to do is find the factors of the last term that will sum or add to the middle term. So what I'm doing is I'm looking for two numbers that when I multiply them, they equal 12. And then I'm looking for the same two numbers that I just found that multiply. I need to make sure that those two factors also add to give me the middle number. Now, little help here or hint here. If the last term is positive, then we know the signs on our two factors must be the same. Remember, in order to get a positive number when you multiply, you either need to do a positive times a positive or a negative times a negative. Now, when this is a positive number here, then we would look at the middle, and that's going to tell us what the two signs will be. So because this problem, my middle term is negative, that tells me the two numbers I'm looking for are both going to be negative. Now what you have to do is start listing all of the ways to multiply to get a 12, and we keep listing them until we find the combination that when I add those two factors, I get a negative 7. So I'm going to list all of my factors of 12, 1 times 12, 2 times 6, 3 times 4. Now remember, they both were supposed to be negative in order to get that negative 7 in the middle. Now that I've listed all of the ways to multiply to get positive 12, now I go back and see when I add these two, do I get 7? No, I get negative 13. When I add these two, I get negative 8. And finally, when I add the very last one I found, I get negative 7. So my two factors of 12 that when I add them give me the middle. So when I go to factor my trinomial, I'm going to set up two binomials here. So I take the x and I split it, because if I were to FOIL this, x times x gives me x squared. So the factors of x squared are just x times x. And then I take the factors of the 12, the negative 3, and the negative 4, and I put them there. Now, what I highly recommend you do when you're factoring these is, if you have time, the way that you would check your answer is you take your binomials and you FOIL them. If it goes back to your original problem, then you've picked the correct factors. So x times x is x squared. Outside gives me negative 4x. Inside gives me negative 3x. And then last gives me positive 12. You add the middle, and you indeed do get x squared minus 7x plus 12. So we did go back. So we did find the right answer when we did x minus 3, x minus 4. Now, when your last term is going to be negative, that's when your signs are going to be different. And when we encounter an example of that, I will elaborate. Let's try another one. Again, you are going to look at the last term. We need to find two numbers that will multiply to give me a 6, but who will also add same numbers to the middle, which is 5. So again, I start listing my factors of 6. 1 times 6, 2 times 3. Now, again, when this sign is positive, we know the signs are the same. So I look over here, this was positive, so this tells me my factors are both positive. So now if I go back and add the 1 times 6 and make it a 1 plus 6, I get 7. And then if I add 2 plus 3, I get 5. So these are my two factors. So I end up doing x plus 2, x plus 3. And again, if you have any doubts, FOIL it. If after you FOIL, if it does not go back to this, then you've either chosen the wrong factor, or maybe you have the wrong signs. Let's try the next one. Here we, yes.
Why couldn't it be -1 and -6?
Because if I do -1 and -6, that gives me -7. And I wanted 5. Does that make sense? All right, next one. Here's the situation now where our last term is negative. So this tells me the two signs, one is going to be positive, one is going to be negative. And the way that I know which factor gets the negative sign is I look at the middle. If my middle term is negative, then my bigger factor is negative. If this were a plus sign, then my bigger number would be positive. So let's try it. So 6 times 1 and 2 times 3 again. But we need negative. So then I look at the middle. The middle number's negative, so my bigger factor out of each pair gets the negative sign. Now I go back to figure out which one works. Is it the 1 minus 6? Well, that gives me -5. Or is it the 2 minus 3? And it's the 2 minus 3, because that gives me -1, which is what I wanted in the middle. Make the two binomials. You factor the x squared, it becomes x and x, and then you put the +2 and the -3. Now, if you'd rather write x minus 3 first and x plus 2 second, you can do that. However, the negative sign must be with the 3 and the 2 must be positive. Same thing on any of the previous examples I did. I could have written the x plus 3 first and the x plus 2 second. Either answer is fine here. Let's try the next one. Notice my last term is positive, so that tells me my signs need to be the same. And the same sign that they're both going to have is the middle, so they're both going to be negative. So two numbers that will multiply to give me 8, but who will also add to give me -6. And they're both going to be negative numbers, because a negative times a negative is a positive. So now I'm going to list all of the ways to multiply to get an 8. 1 and 8, 2 and 4, and they're all negative. Now if I go back and add them, this gives me -9, this gives me -6. So this is the one I want. So again, set up your binomials, x and x, and then the two factors. And you're done. These are the easy trinomials. Let's do some more. Next one, negative 24. So two numbers that multiply to give me negative 24, but who also add to give me negative 5. Again, because this is a negative number, I know my signs are different. So I'm going to come over here, check out my middle sign. It's negative, so that's the sign on the bigger number. So my bigger factor is going to be negative. So let's start listing them. 1 times negative 24. Don't always forget about that obvious one. That's one that students tend to forget. Then I have 2 times negative 12. Now, as we're making our list, add them at the same time. So this gives me negative 23 when I add them. This one gives me negative 10. I still haven't gotten to the 5 yet, so let me try the next one. 3 times negative 8. Oh, there's my magic pair. So again, I'm going to fill in my binomials with those two terms. X plus 3, x minus 8. And again, especially when the signs are different like this, it'll really help if you FOIL it. Because let's say you found 3 and 8, but let's say instead you did x minus 3 and x plus 8. This one's wrong. You don't get credit for it because this will not give you a negative 5 in the middle. It gives you a positive 5. So be very careful where you put the appropriate sign.
How was it again that you knew that the greater number would have the negative sign?
So whenever this number, the last number is negative, you're going to look at the middle, and the sign that's on that middle number, that's the sign of the bigger.
So when the last number is negative and the middle number is negative 2, the greater one has the negative?
Yes. But if it were like this, x squared plus 5x, then the greater number would be positive.
Okay.
All right. Next one. Factors of 1. 1 times 1. But if I go back and add those, 1 plus 1 gives me 2. I wanted a 1 in the middle. When this happens, then you're going to say that you cannot factor it. So if you've gone through all of the options and you just can't find a pair of factors that give you the middle, then possibly it could be one where you cannot factor it. So you can either put cannot factor, not factorable. You could even put just NF. Some textbooks in Algebra 1 courses tell you to list this as prime. Other textbooks would just rewrite the problem and leave that as the answer. So I'll accept any of these. However, remember, if you see this on a standardized test or as a multiple choice question, realize that the answer could be any of these. Let's try the next one. Factors of negative 18. So again, two numbers that will multiply to give me negative 18, but the same two factors that when I add them, I get negative 3. Notice the last term is negative, so I need to take a peek at the middle term. It's negative, so that tells me my bigger factor is going to be negative. So I'll make my list. 1 times negative 18. This one gives me negative 17. 2 times negative 9. And that gives me negative 7. 3 times negative 6. And there's my magic numbers. Positive 3, negative 6. So x plus 3, x minus 6. Next one. Factors of positive 2. So two numbers to multiply to give me 2, but the same two numbers that add to give me positive 3. Notice it's positive, positive, so both signs will be positive. So I'm going to do 1 times 2. There's only one way to do it. And then 1 plus 2 is 3. So it factors into x plus 1, x plus 2. And you're done. Now the fun begins. The more challenging trinomials. We are actually going to have a number in front of x squared. Notice here it says a is not equal to 1. So all that means to us is that when I have a trinomial, I'm now going to have a number in front of x squared. And this is where we're going to bring back factor by grouping. Now, there are all kinds of tricks out there that help you with factoring trinomials. If you know one of those tricks, I'm more than happy to say, go ahead, use it. However, I found in the past when I teach tricks, students mess up the tricks. They get confused. So it's better if I stick with one standard technique and then move forward from there. Now, there's two options that I'm going to show you from the notes today. The first one is trial and error, or guess and test. The problem with trial and error is in order to find the factors that work, you end up having to do a whole bunch of FOIL problems until you find the factors that magically work together. The second option is the one that I highly recommend, and that is factor by grouping. Now, some of you are going to be really good. When the numbers are small, like this example, you'll be able to do it pretty quickly by trial and error. So let me demonstrate what you need to do for trial and error. So when you're doing trial and error, you're going to list the factors of the first term. So the factors of the first term. Now, not only do we have to worry about the 15, now we also have to worry about the 2. So the factors of 2x squared are going to be 1x times 2x. Factors of 15 are either going to be 15 and 1, 3 and 5. And again, these need to be negative. So one of them is going to be negative. So now what we have to do is trial and error. So again, I would set up my binomials. I'm going to put 1x here and 2x here. So the factors of the first term go in the first spot here. Then what you're going to do is you're going to take these and you're going to put them in here. First, you'll try the 1 and the 15. Remember, it was a negative 15, so one of these has to be negative, one has to be positive. And now you'll put them in here, and then you FOIL it. If it goes back to the original, then you got lucky and you picked the right ones. If not, then you got to change it up. So if I do this, and really all you're testing is outside and inside, because that's all we're really doing is checking to see if we get the middle. So this gives me 15x for outside, negative 2x inside. I get a negative 13. This guess is wrong. Now I got to try another guess. So let's say I put still the 1x here, and let's say now I change the sign on the 1 and make the 15 negative. And now I try it this way. I get negative 15, positive 2, and now it's a negative 13. That one failed. Now I'm going to try the 3 and the 5, because obviously it's not 1 and 15. So let me put, again, the x and the 2x. and put a 3 and a 5 here. Let's try a plus sign and a minus sign. So now if I test, outside gives me negative 5x, and inside gives me positive 6x. Wow, I found it, 1x. I finally got the middle, so this is my answer. So you basically just have to list the factors and then figure it out almost like a puzzle until you find the one that works. Now I'm going to teach you option 2, which I prefer. Okay, this way takes too long, especially if your numbers are really big. You're going to waste too much time foiling too many problems. So let's try option 2. Option 2, here we go. Same problem now. Let me rewrite it down here. 2x squared plus x minus 15. Step number 1, multiply first and last terms. 2 times negative 15. I get negative 30. Actually, I get negative 30x squared. But really, all I'm focusing on is the negative 30. Now what I need to do is list the factors of this number that, again, sum to the middle term. So now I'm going to find two numbers that when I multiply them, I get negative 30x squared, but when I add them, I get 1x. So my factors of 30, I need to start to list them. Again, the signs are different, so I need, because it's negative. So 1 times 30, 2 times 15, 3 times 10, and again, remember your sign's going to be positive, so I'm going to put negative signs here. And then 5 and 6.
When there's a negative at the end but a positive in the middle, that's when you put the negative sign on the smaller number?
Yeah, so when whatever sign's in the middle, that's the sign of the bigger factor. So my middle number is positive, sorry. My middle is positive, so that's why my bigger number here has the plus sign. The bigger number always gets the sign in the middle. Now I need to go through and add these to figure out which one gives me a 1. So this gives me 29, this gives me 13, this gives me 7, this is the magic. Okay, so now it's 5x, negative 5x times 6x, and negative 5x plus 6x gives me what I need. Now what we're going to do is we replace the middle term with these two. And we turn our trinomial into a 4-term polynomial, and we factor by grouping. So I'm taking the 2x, I'm rewriting it. I'm now replacing this positive x with these two factors. So minus 5x plus 6x, and then I just rewrite the minus 15. So all I've done is taken out the x and replaced it with the two factors I found. Now I factor by grouping. So let me rewrite it down here. So 2x squared minus 5x plus 6x minus 15. Now, I also want to show you that it doesn't matter the order that you put the two factors in. So the first time I do it, I'm going to put the negative 5 first, the negative 5x, and then over here, I'm going to put the negative 5x second. So this was yesterday's lesson. We're going to make a red group and a blue group. And now we factor by grouping. GCF of red is going to be x. GCF of blue is 3. And now remember, these need to look the same, which they do. So just write it once. And then now take this red and this blue, and it goes together. And you're done. On these harder trinomials, I highly I highly recommend that you FOIL it. It'll double check that you've picked the right numbers and the right signs.
Wait, Miss Corey, where did you get the equation that you have on the right to the black line?
This one?
Yeah.
All right,
It's different than the one on the left.
Right, I'm gonna do the same thing now. So here was my original. Let me write it on top. I just want to show you it doesn't matter if you put the 6 first. Like, see how I put it second over here? And I put the -5 first? I'm going to show you get the same answer. So this was my original. So I rewrite the 2x squared. I rewrite the -15 here. Remember, what you're replacing is this plus x with the 2 factors you just found.
So you just flipped it?
Yeah.
The 2, okay.
So
Thank you.
now I'm going to do a GCF. GCF here is 2x. And you're left with x plus 3. GCF here is -5. And now these look the same. So you write x plus 3. And then you take this 2 and this -5, and you're done. Notice it's the same answer. You can choose which way you do it. You can either do this left side or the right side. You don't have to do both. You pick. Let's try another one. I'll just do it one way, but I just wanted to put it out there that it doesn't matter how you put those 2 numbers in, you get the same answer either way. Let's try the next one. Step number 1, multiply first and last. 6x squared. 2 numbers that multiply to give you 6x squared. Same 2 numbers are going to need to add to give you a -5x. So now I list my factors of 6. 1 times 6, 2 times 3. Notice it's a positive 6x. So this tells me my signs are the same, and the signs that they will both have is this sign of this middle. So they both have to be negative. So now when I put them in here, the one I want is this, because -2x plus -3x gives me -5x, times -3x gives me positive 6x squared. So now I'm replacing -5 with these 2 numbers. So the 2x squared gets rewritten. Replace 5x with -2 and -3, and then just rewrite the 3. Make your groups red, blue. GCF of first group is going to be 2x. GCF of second group is going to be -3. Because remember, after you divide, you want the 2 parentheses to look the same. They look the same. They both have x minus 1. So I write that. And then I take the 2x and the -3 and put it together. And you're done. Let's try the next one. Numbers are getting a little bit bigger. 2 times negative 27. I'm looking for factors of negative 54. Now, you could put the x squared, but essentially we're...
Did you get the 54 again?
How do I get it?
Yeah.
First times last.
Oh, okay. So you do that every time?
Yes.
Okay.
So now, multiplying two numbers, and I'm looking to get negative 54x squared. I want to add two numbers, and I'm looking for negative 3x. Now, this is negative, so this tells me my signs are different. And the way that I know which number of my factors gets the negative, it's the middle sign. So the middle sign goes on the bigger number. So I always write the little factor here and the big factor here. So my big factor gets the sign in the middle. So let's start listing 54. 1 times 54, my bigger factor is 54, so it gets the negative. 2 times negative 27. 3 times negative 18. And again, as you're doing these, add them in your head. This is negative 53, negative 25, negative 15. I haven't gotten to negative 3 yet. I got to keep going. 4 won't go into 54 evenly, and neither will 5, but 6 will. So 6 times negative 9, and when I combine that, I get the negative 3. So my two factors are going to be 6x and negative 9x. So again, rewrite the 2x squared. Replace this with the two numbers I just found. And rewrite the 27. Make your groups. Red and blue. GCF of first is going to be 2x. I'm left with x plus 3. GCF of second group is negative 9. And again, you get x plus 3. Again, these need to match. Let's say you only thought it was going to be a negative 3 as your GCF. Then you would have seen that these two things that I just underlined in green wouldn't match. So now you take the underlined green and then take these two and put them together. Again, you can always FOIL it. If it doesn't go back to the original, you've done something wrong. Let's try the next one. A little bit bigger number. 8 times 18. 144. Two numbers to multiply to give me 144. And two numbers to add to give me 51. And again, this is positive. Signs need to be the same, and they're both going to be positive. 1 times 144. This gives me 145. Then 2 times 72. That gives me 74. 3 times 48. Oh, wow, there we go. 3 plus 48 is 51. Here are my two numbers. So I rewrite the 8x squared. I'm replacing 51 with these two numbers. And then rewrite the 18. Make your groups. Red, blue. GCF of the first group is just going to be an x. GCF of second group, that is going to be a 6. Rewrite just this. And then take the two whites, x plus 6. And you're done. Now, whenever you do these factoring problems, always make your x squared term positive. So on this one, I'm going to factor out a GCF of -1 to begin with.
Wait, which ones do we always make positive?
The x squared. It's going to help us later on when we find zeros. So divide everything by -1. And
Wait,
now,
I'm sorry, can you repeat why you're dividing everything by -1?
it's going to help us later on in the course.
But we're not doing the same thing that we've been doing every other time? Like
No.
multiplying?
No, we are.
-6? Oh.
But we're not going to leave it a -6. We're going to make it a +6. So you always want to make the number in front of x squared positive, and the way that I do that is I can factor out a greatest common factor of -1. So now what I need to do is the same thing I've been doing. I'm going to multiply first and last. I get -18. Two numbers to multiply to give you -18, but who add to give you -17. Now, believe it or not, sometimes the most obvious factors are the ones that students overlook. So notice how I've been doing this all along. I've been writing the 1 times the number because this is the first time that we're going to use it. Because 1 times -18 gives me -18, and when I add 1 plus -18, I get the -17. So this one is actually the 1 times the number. You're going to write the GCF, then you're going to write the 6x squared again, replace the 17 with these two numbers, and then rewrite the -3 on the end. Still doing the same thing. Only difference is I have that -1 waiting outside. Red group, blue group. GCF of red is just going to be an X. GCF of the blue group is going to be -3. This is the same. So you're going to write the GCF, then you're going to take that 6x plus 1 that was the same, and then put these two together. And you're done.
Wait, what does it say in the second parenthesis by the 3? It goes -3 in the parenthesis.
This 6x plus 1. This one right. This one right here.
Yeah.
Yeah, 6x plus 1.
So the answer, we keep the -1 out there?
Yes. Whenever you factor out a negative or any kind of GCF, it never goes away. You always need to remember to keep it in your answer. Otherwise, you're going to lose points when we test or quiz. All right, so this is all the information you need to do the P.4c homework. The next section of these notes, which was originally part 4, is the instructions are to factor completely. So it's nothing new. All we're going to do is combine all of the techniques I've shown you into one problem. So what you should always do first is look to see if you have a GCF first. If you do, you factor that out first, and then you're going to look to see, do I only have 2 terms? If that's the case, then I potentially could have the difference of 2 squares or the sum or difference of cubes. If I have 4 terms, then I'm going to factor by grouping. If I have 3 terms, then it's either going to be a perfect square trinomial Or it could be the traditional factoring that I just finished teaching you. So let's try the next 3 examples, and then I'll finish the last 3 tomorrow. So the first one, notice the instructions say factor completely. On the test, it's not going to say factor this difference of 2 squares or factor this trinomial. The instructions are going to say factor completely, and then you have to know which technique to use. So always, always, always look for a GCF first. This one has a greatest common factor of 12. I'm going to divide both of them by 12. Now notice what remains is now the difference of 2 squares. Now I have to keep factoring, and then this one becomes x plus 2 and x minus 2. Do not forget to write your GCF out front. Then the next one, same thing. I'm going to pull out a GCF, and that GCF is an x. And after I do that, again, I'm left with the difference of 2 squares. So then I'm going to factor it into x plus 4, x minus 4. The last one, again, remember, we want this x squared to be positive. So again, I'm going to pull out a GCF first of -1. Now what remains is a trinomial. You can either factor by grouping like I just did, or if you're good at recognizing that this is a perfect square and so is this, then you just do the perfect square trinomial where you just square root the 9, square root the 1, and put the sign of the middle term, and it's a binomial squared. Remember, we did the test. We square rooted the 9 and got 3x. We square rooted the 1, we got 1, and then we doubled it. If that gave us the middle, then we knew the answer was a binomial squared. Now, you could also do it like I just did and do it the long way with the factor by grouping. You could also write your answer as 3x minus 1, 3x minus 1. Either way would be acceptable. So when the instructions say factor completely, you're going to use any of the factoring techniques that I have taught you in section 4. I will finish the last 3 examples tomorrow. Go on to the next one. It says factor completely. So always, always, always look for a GCF first. Now, before I even do this also, I'm going to put it into standard form. So I'm going to put my negative 3x to the third first. Then I'm going to move the 9x squared and then put the 12x last. Now I'm going to look for a greatest common factor. And that GCF on this problem is going to be -3. Actually, -3x. They all have the variable x. So I'm going to write the GCF on the outside, and now I'm going to write what remains. So I get x squared minus 3x minus 4. Now I have a trinomial that I can factor. I'm looking for the factors of -4 that when I add them give me -3. So again, you're going to write your GCF. My A term is 1, so I'm just going to set this up. And now factors of -4 are 1 and 4, 2 and 2. One of them has to be negative, and the one that works is the first one. So this becomes x minus 4, x plus 1. The next one, again, is the difference of 2 squares. So what I'm going to do here is I'm going to square root the first one, square root the second one. Do it in a color that shows up a little better. So remember, you're going to create your 2 binomials. So the first term is the blue one, square rooted, so x squared plus 8. And then I square root the 36x squared. That becomes 6x. And then remember, one gets a plus sign, one gets a minus sign. Now what I need to do is put them into standard form so I can see if they can be factored further. So I'm going to go ahead and rewrite this as x squared plus 6x plus 8. And this one, x squared minus 6x plus 8. And now I can actually factor both of these trinomials. For this one, I'm going to look at the factors of 8 that give me 6. And that's going to be x plus 2, x plus 4. Same thing over here. Factors of 8 that give me negative 6. So this tells me my signs are going to both be negative. And you're done. I can't factor any further. 2 more examples. Notice on this one, I'm going to look to see if there's a greatest common factor or anything I can do here. And there is no GCF. It's a 4-term polynomial, so I'm going to factor by grouping. So let me do different colors here so they show up. I'll make a green group, and I'll make a yellow group because the background's red and it may not show up. All right, so I need to find a greatest common factor of my green group, which is going to be x squared. And then what remains is going to be 3x plus 1. Now a GCF of yellow, and that's going to be negative 9. And then I'm left with 3x plus 1. Again, these look the same, so you're going to write 3x plus 1. And then we're going to take the two things that are outside here, and x squared minus 9. Notice x squared minus 9 is the difference of 2 squares. This one I can keep going. So rewrite this one, and then factor the blue. The blue becomes x plus 3 and x minus 3. And now you're done. Last example. This one, we're going to pull out a GCF of 2x minus 1. GCF is 2x minus 1. And now after we divide the first term, these become 1s. I'm left with a 4x. Divide this one, take 1 away from here, and now I'm left with 2x minus 1. I can combine these two like terms. This becomes 6x minus 1, and then just drop this one down. And I'm done. Remember, on any of these factoring questions, you can always FOIL to check. So you can always multiply it back or distribute it back, and it should go back to your original problem. If it doesn't, you've made a mistake somewhere, either chosen the wrong factors or maybe used the wrong signs. So that is it for the factoring section.